Okay, what's going on, folks? We've got a pretty short lesson for today. Um, so in today's lesson, you're going to learn how to break a diagonal force into x and y components. You're going to take notes on drawing 2D force diagrams and breaking vectors into components. And then you're going to follow along with the examples and complete the practice problems on drawing 2D force diagrams and breaking up vectors into components. So often forces do not only act in one dimension, right? So by one dimension, I mean like forward and back, up and down, left or right. Instead, they'll act in 2 or 3 dimensions because many forces are applied diagonally or at an angle, right? So to make this easier to model, physicists will often break up the diagonal forces into x and y components so that they can determine the net force in both the x and y directions. So here we've got an example. We've got a gymnast. This gymnast is going to pull themselves up on the rings. The gymnast has a mass of 56 kilograms, and the rings are pulling on each arm with 250 newtons of force. So you might think of it that the gymnast is pulling on the rings with 250 newtons of force, but Newton's third law says for every action there's an equal and opposite reaction. So that means that if he's pulling that hard on the rings are also pulling that hard on him. And he's pulling at an angle of 30 degrees to the vertical. So we're not going to use any of these numbers today, but we're going to use these examples in our next lesson, and we'll figure out exactly what that means and how we can use that to determine his components in the x and y direction. So you're going to draw a diagram on the gymnast, and then you're going to break the tension forces into x and y components. So first thing we're going to do is draw a box around the gymnast, and we'll put a dot at the center. We know that there's going to be a force of gravity acting downwards. And then we know that there's going to be 2 tension forces, right? One tension up to the left, one tension up to the right. Okay, and so what we're just going to do is we're just going to draw 2 arrows. Those arrows need to be at a right angle to one another. So one's going to go straight to the left, one's going to go straight up. And we're going to start at the tail, and we're going to end at the point of that first tension. Whoops. So we're going to go one arrow, So we're going to go one arrow over, and then one arrow. Try that again. One arrow over, one arrow up. One arrow over, one arrow up. Right, and those arrows should be at a right angle to one another. And then we're going to do the same thing with tension number 2. Right, one arrow is going to the right, one arrow is going up. And those are the x and y components. In our next lesson, we'll learn how to calculate the values of those x and y components using trigonometry. Okay, so 4 friends are playing tug of war. The women are pulling with 350 newtons of force, and the men are pulling with 550 newtons of force. All of the friends are pulling at an angle of 45 degrees from the vertical. Draw a force diagram on the knot in the middle. Break the forces into x and y components. So there's the force diagram on the knot. Jesus Christ, the bell's in here. And so then each person's pulling with a force, although I guess maybe I should have made the arrows for the women a little bit shorter since they're not pulling as hard as the men in this example. And so each one of those is a tension. You could call them tension 1, 2, 3, and 4 if you wanted to. They're all tension forces though. Okay, so let's start with this guy up in the corner here. We're going to break his up into components first. Whoops. So look, one arrow to the right, one arrow going up. Again, they meet at a right angle, right? So one arrow is going straight up and down, one arrow is going to the right. And it starts at kind of like the tail of this vector and then goes all the way up to the head of it. And then it'll be the same thing for this lady in pink here. We've got one arrow going to the right and then one arrow going down. Okay, so next let's do these two on this side. So for the X component, it'll be going to the right here. And then for this lady in black, the Y component will be going straight up and down. Right? Again, we want it to kind of, I didn't actually do a super good job of drawing this one. We want the arrow to start at the tail of this one here, and then we want the vertical one to end at the head of this one right here. So maybe not my best drawing. Okay, and then we'll do the same thing for this guy down here. So it's going to the right, and so then his arrow will be going straight down. So you can kind of see we're going to get 4 different triangles out of this. And so then in tomorrow's lesson, what we're going to do is we're going to be solving for the lengths of those triangles, because that's what we'll be using to determine how strong each force is in the X and Y direction. Got a couple practice problems here. A woman pulls an ice flat on the ground with a force of 500 newtons at 55-degree angle to the vertical. Draw a force diagram on the block of ice. Break the tension force into X and Y components. Problem 2, 3 men are in a tug of war. The man with a beard is pulling at a 700 Newton force straight to the left. The other men are also pulling with a 700 Newton force, but they are pulling at angles of 50 degrees to the vertical. Draw a force diagram on the center of the tug of war and break the tension forces into X and Y components. So we'll try going through these together as a class tomorrow. And then in our next lesson, we'll actually learn how to calculate the values of those X and Y components. Okay, so thanks for watching.